Hi everybody, hope that you're all doing well. We're going to make an entrance into Chapter 4 in the Math 71 course. And Chapter 4 is pretty unique to Math 71, with the exception of the very first section of Chapter 4. Everything will be pretty exclusively pertaining to this course. And we're talking about inequalities, primarily linear inequalities. Linear inequalities primarily meaning the variable term that we're going to be working with will be a term that will be taken to the power of 1, sort of like a first degree term. And in 4-1, like I mentioned, this section will be somewhat review because you would have seen it in the Math 51 course. And what we are looking at in 4.1 is solving linear inequalities. And we're going to solve a total of 6 of them. And each one of them that we're going to solve, we're going to be doing 3 items. Item number 1, we're going to go through the steps and actually solve the inequality. And then we're going to take the solution of the inequality and do 2 different things with it. We're going to graph it on a number line. And then finally, we're going to express the solution using interval notation. Now, over on the right-hand side of this board, there are 2 key rules that I believe are important to follow when we're solving linear inequalities. And I want to emphasize both of them. They are both, in my mind, extremely important to deriving a good solution. Step number 1. Always put the variable term on the left side of the inequality symbol. Always put the variable term on the left side. Reason? It'll be much easier to graph the solution, and it will be much easier to express the solution using interval notation if we make sure that the variable term is always placed on the left side of the overall inequality statement. And item number 2, it's a rule and it must be followed or we won't get correct solutions. And it's not a new rule. You have dealt with it in the past. When you're solving an inequality, when you multiply or divide both sides of an inequality by a negative number, you must reverse the inequality symbol to make a true statement. Now, just paraphrasing that rule again. When you multiply or divide both sides of an inequality by a negative number, you must reverse the inequality symbol to make a true statement. So let's move into this review section and let's solve number 1. We solve a linear inequality in the same manner that we solve a linear equation. The only difference is, instead of an equal sign, we'll have an inequality symbol that we'll be dealing with. So number 1 says 4x minus 3 is greater than negative 23. our goal to get the variable x alone on the left side. So we're going to have to get rid of that unwanted term of negative 3. And we get rid of it by performing its opposite. So positive 3 on the left, positive 3 on the right. I'll draw a line. We'll be left with 4x on the left is greater than, combine the like terms, negative 20. Now we've got to divide both sides by a positive 4. And because we're dividing both sides by a positive number, nothing happens to the inequality symbol. It remains the same. So over 4 and over 4. And now we have our solution. X is greater than negative 5. There's the solution. We've solved it. Now we're going to graph this solution on a number line. And we don't have to make the number line so involved with showing so many values. Here's all we're going to require that you do. Make a number line with arrows on each end. The first number that you do need to show on the graph, on the number line, is 0. And I'm going to place 0 maybe somewhere towards the right-hand side of this portion. So I'm making like a tick mark through that number line, and we'll label it a 0. And then this negative 5 portion of the overall answer, this negative 5 is classified as an endpoint. It is the point where the graph of the inequality is going to begin. And since it's a negative 5 and I've got 0 placed there, negative 5 has got to be positioned to the left of 0. And you can place it anywhere to the left. I'll take it out a ways and I'll label it negative 5. You don't need to show negative 1, negative 2, negative 3, negative 4, and you don't have to show any positive values. Then, because I used black to primarily set up that number line, now we'll show the graph of it. X must be any real number that is greater than negative 5. It cannot be equal to negative 5 because there is no equal sign attached to that inequality symbol. The value of x must be any real number that is greater than negative 5. Come down on the number line, and right at the point of negative 5, we're going to put a parenthesis. Not a bracket, but a parenthesis. The parenthesis is going to indicate that the graph is going to begin at negative 5, but that negative 5 is not one of the solutions. So we use a parenthesis. And the parenthesis is going to open up in the way that the inequality symbol is pointing. The inequality symbol is pointing to the right. And so when we make our parenthesis going right through negative 5, we make sure that that parenthesis is projecting or pointing in the same direction as the inequality symbol is pointing. So it opens up to the right. And then from that point, we shade the number line, including the arrowhead. And there's the graph solution. X can be any number greater than negative 5. And now the final thing that we'll do, and I'll put it right down here at the bottom, we'll show the interval notation. We bring down this parenthesis in the same way that we see it on the graph. And next to that parenthesis, we put the end point of negative 5. we put a comma. And since the smallest value is -5, the largest value has to go here. Well, this graph is going infinitely positively. It's moving in a positive direction forever and ever and ever. And we use the positive infinity symbol. And next to an infinity symbol always gets a parenthesis. Done. Process, solution. Graph, interval notation. Let's go to number 2. (3x plus 1) is greater than 7x negative 15. Variable terms are on both sides of this linear inequality statement. Rule number 1 that we mentioned a few minutes ago: when you're solving an inequality, always make sure that the variable term is placed on the left. So even though 3x has a smaller coefficient than the coefficient of 7 on 7x, that's immaterial to me. The 7x is going to move from the right-hand side over to the left. And the +1 is going to leave the left side and move over to the right. So here we'll do it on one line. -7x on the right, -7x on the left. Move him. -1 on the left, -1 on the right. And very carefully on the left-hand side, -7x added to 3x is a -4x is greater than -15 added with -1, -16. And now the step is to divide both sides by a -4. If Kristen can just move that camera right back over here again briefly. When you multiply or divide both sides of an inequality by a negative number, you must reverse the symbol. Back over here, to get x by itself on the left, we've got to divide both sides by a -4. We're dividing by a negative. The moment that you divide both sides by a negative, that inequality symbol must be reversed to make a true statement. So I'm going to leave that statement right there, but I'm going to come down and rewrite the -4x, and we're going to divide it by a -4. And folks, the moment that you divide by a negative, you should reverse him. Not later, but you should reverse him now. So we'll change it from is greater than to is less than. Is less than -16 divided by that -4. We have activated the rule correctly. And now we have x is less than +4. There's the solution. I'll stick the graph right here so it's somewhat elevated. Make a number line. You need to show 0, and you need to show this endpoint of 4. So I would tend to put the 0 towards the left and move it out on the positive side to 4. And now we'll go to the graph. We're going to begin at the endpoint. And that endpoint is either going to have a parenthesis going through it, or it's going to have a bracket. And that is based, once again, on the inequality symbol. The symbol does not contain the equal sign. It's merely is less than. So we're going to make a parenthesis again. And the parenthesis is going to open up in the same way as the symbol is pointing. This inequality symbol is less than is pointing to the left. the parenthesis will go through the positive 4, and it will project to the left as well. It's projecting to the left. The inequality symbol is pointing to the left. And now we will shade everything from that parenthesis to the left. And hopefully this will stand out. Arrows as well. There's the graph. And the interval notation, bring down the parenthesis just like you saw it going through positive 4. Put a positive 4 right next to it, put the comma. It's moving infinitely again, and in a negative direction this time. So it's moving in a negative infinity direction, negative infinity, parenthesis, process, graph, interval notation. I hope you're saying easy peasy, because that's what it is. It's a straightforward mechanism. Let's go to 3. Maybe I'll try to do this one in blue. Number 3. 3x over 10 plus 1 is greater than or equal to 1/5 minus x over 10. We've got to get rid of the fractions. So we're going to multiply both sides of this inequality by the LCD of all the fractions that we see. He's not a fraction, but he's going to get treated in a moment. Denominator of 10, 5, 10. LCD has got to be at least as big as the largest of the denominators up there. 10 is the largest denominator, and 10 is the LCD, because not only does 5 divide into 10, but 10 divides into 10. So, bracket left, bracket right. Show on the left, we're going to multiply the left-hand side by 10, and show on the right-hand side that we're going to multiply it by 10. We don't have to worry about reversing any inequality symbol because we're not multiplying by a negative. We're multiplying by a positive 10. Folks, you've seen me do it before. Let this 10 be reserved for this first term. Take another 10 and maybe put it right about there, and that 10 will be reserved for that positive 1. Let this 10 that we've already written down, let it be reserved for the 1/5. You can take another 10 and maybe put it right there, and that will be reserved for the negative 1x over 10. 1, 2, 3, 4 terms have to get treated by 10. 1, 2, 3, 4 times I wrote that 10. Here we go, let's cross cancel. The 10s cancel to 1s. 1 times 3x, 3x. Positive 1 times 10. Nothing's canceling. It's just an integer. 1 times 10, positive 10, is greater than or equal to, let's cross cancel. 5 goes into itself once, 5 goes into 10 twice, 2 times 1 is 2. Negative times that positive, negative, the 10s cancel out to 1s, and we're left with a negative 1x. You don't have to show the 1 there, but I did. We have variable terms on both sides now, but no fractions. He's leaving because I want him over to the left. I want him on the left. I want that negative 1x moved over to the left. And that positive 10, he's going to the right. Let's do it in one line. Positive 1x, positive 1x, negative 10, negative 10. 3x added to 1x, 4x. They go. Positive 2 added with a negative 10, that's going to be negative 8, but let's not forget that inequality symbol. Negative 8, they cancel. We're going to divide both sides by a positive 4. We don't have to reverse, so we just move into it. Over 4, over 4, x is greater than or equal to negative 2. Let me show the graph right here. We got to show 0, and we've got to show the endpoint of negative 2. I'm going to stick the 0 right about there, and the negative 2 right about there. There's the setup. Now look at the inequality symbol. This time the inequality symbol includes the equal sign. It's greater than or equal to negative 2. That means x can be negative 2. And to show that it can be negative 2, we're going to put a bracket. And we're going to make the prongs of that bracket project in the same way as the inequality symbol is pointing. It's pointing to the right. We're going to project the bracket to the right, emanating at negative 2. So make that bracket go through that negative 2. It begins there, it counts because we've used a bracket, and now we'll shade to the right because the inequality symbol is projecting to the right. We'll shade to the right, including the arrowhead. There's the graph. And now the interval notation. Bring down that bracket, projecting in the same way as it did on the graph. Put that negative 2 right next to it, put a comma, and the positive infinity symbol. He gets a parenthesis, done. Now I hope I'm not rushing. This is review, but I do want to give you time to kind of pause for a little bit and see what we're wanting. Solve, graph, interval notation. Let's do 4, get it out of the way. X plus 3 over 4 is greater than or equal to x minus 2 over 3 plus 1/4. Fraction, fraction, fraction. Look at the inequality symbol. The equal sign is attached. Just looking headward, just looking down the road a bit, we'll be using brackets. We won't be using a parenthesis. We'll be using a bracket. Let's get rid of the fractions. 4, 3, 4. It's got to be at least as big as 4, the LCD does. And it can't be 4, because 3 doesn't divide into 4. But it will be 12. LCD. Tuck. Tuck it. One term, second term, third term. We're going to write the 12 3 times. The first time, there. The second time, next to this fraction. The third time, next to this one. Here we go. Let's cancel. 1, 3. I believe it would be wise to write 3 times the quantity of x plus 3. I don't know if I would do too much. Is greater than or equal to, let's cancel, 1, 4. 4 times the quantity of x minus 2 plus cross cancel. 4 goes into itself once, into 12, 3. 3 times 1 is 3. Now let's distribute so we can clear the parentheses. 3x plus 9 is greater than or equal to 4x negative 8 plus 3. Let's bring it down one more time so we can combine those like terms on the right-hand side. 3x plus 9 is greater than or equal to 4x, combine them, negative 5. The 4x, he's going to move over to the left. The positive 9, going to move over to the right. Negative 4x, negative 4x, negative 9, negative 9. On the left-hand side, we have a negative 1x, the 9's go, is greater than or equal to negative 14. Now, I'm going to erase a little bit of this information up here because I'm already down here at the bottom and I don't want there to be an issue here. So I'm going to erase some of this stuff. Negative 1x is greater than or equal to negative 14. Next step, we're going to have to divide both sides by a negative 1. That means we're going to have to divide both sides by a negative number. And that means reverse. So let's do it correctly. I'll elevate it right here. Negative 1x divided by negative 1. You reverse him now. You change him to is less than or equal to. Then bring over the negative 14, and that's going to get divided by negative 1. You see, folks, if you leave this at this step, if you leave it greater than or equal to, you've actually written down a false statement. Because the moment that you're dividing both sides by a negative, you've got to reverse, and we did. Now we'll get x is less than or equal to a positive 14. I'll put the graph right here. I think there's room. You don't have to make it so long. The end point is positive. That means I'm going to want the 0 maybe towards the left-hand side of the portion of the graph that I've made. Then take the positive 14 and you can put them anywhere on the positive side. And now let's put the right symbol at positive 14, which is going to be a bracket because the equal sign is attached. And the bracket is going to have to open to the left because the inequality symbol is pointing to the left. So make that squared bracket, that bracket going through 14. That tells us that 14 is one of our solutions, plus all of the real numbers that are going to be less than 14. And that's why we're going to shade to the left. He's pointing to the left, shade to the left, including the arrow. There's the graph. There's the graph and the interval notation. Make that bracket in the same way as you saw it on the graph. Put the 14 next to it, put a comma, get that negative infinity. He gets a parenthesis. Done. All right, now those are the primary ones. Now I want to get 5 and 6 done. Let me make a comment about 5 and 6 while I'm erasing. 5 and 6 are linear inequalities where each one of these is going to give us a unique looking solution. There's something special about 5 and 6. Let's take a look at number 5. 3 times the quantity of x plus 1 is greater than 3x plus 2. Let's distribute on the left-hand side by the 3. 3x plus 3 is greater than 3x plus 2. My eyes on him. Not this guy. He's already on the left. My eyes are on him. He's got to move to the left. Opposite. There. There. This positive 3, which is on the left, move to the right. Negative 3, negative 3. And then we notice unique situation. We have lost the variable terms on the left. We didn't expect that, but they're gone. And they're gone on the right. So we have completely lost our variable term. It's been eliminated completely. And when that occurs, that's an indication to a unique solution. So let's go one step further and see what we have. They canceled. They canceled. We're left with 0 on the left. Bring down the greater than symbol, and let's see what we have on the right. We lost it, and we picked up a negative 1. Now, here's what we do. When we are solving a linear inequality, and we happen to lose our variable term, it gets completely eliminated. You look at the numerical statement that you're left with down at the bottom. None of it will be variable because they left and they left. Look at your numerical statement. And here's what we consider. If the numerical statement is true, that means that the solution of our inequality is all real numbers. If it's true. If it's false, it means there is no solution to the inequality. So let's look at our statement. 0 is greater than negative 1. If that's a true statement, and it is a true statement, because 0 is greater than any negative number, 0 is greater than negative 1, it's a true statement. That means the solution to our inequality is all real numbers. And so I'll write that first. There's the solution. You don't stop there just because he's true. You write down, because he is true, that all real numbers will satisfy this inequality statement. So that's our solution. Now the graph. You make a number line. And if you wish to put 0 somewhere on that number line, not because you see 0 there, that's not because of him, just if you want some order involved with that number line, if you stick 0 somewhere, that means all the negatives would be to the left and all the positive real numbers would be to the all to the right. Because our solution is all real numbers, your graph will be a graph that is shaded completely. The arrow on the left gets shaded, the arrow on the right gets shaded, and the rest of the line gets shaded. I'll put it in black. Black, black. The entire number line gets shaded. The entire number line shaded indicates all real numbers. And then finally, the interval notation for all real numbers, it's nothing but infinity symbols. A parenthesis on the left, a parenthesis on the right, a negative infinity on the left, comma, a positive infinity on the right. Done. You lose the variable term. Look at your numerical statement. If it is a true statement, the solution to the inequality is all real numbers, the graph darkened in all the way, and the interval notation, negative infinity, comma, positive infinity, parentheses on each end. That's unique. Now let's look at number 6, the other one. Won't take long. Number 6. 5x is less than 5 times the quantity of x minus 3. Bring down the 5x on the left. Bring down the is less than. Distribute. No, I'm not looking at him. I'm looking at him because I don't want him on the right-hand side. I'm moving him. Negative 5x. Negative 5x. We're losing the variable term here. We know we're losing it here. We're losing it on both sides. Let's simplify this. We're left with a 0 on the left. Is less than negative 15. We lost the variable terms. Now look at the numerical statement. Let's see if it's true or false. If it's true, like the last one that we just did, it would be all real number solutions. But this one, unfortunately, is not a true statement because it's saying 0 is less than negative 15. 0 is not less than negative 15. 0 is greater than negative 15. So this is a false statement. I'll just write that off to the side. You don't have to, because it's actually not really part of the overall solution, but it is a false statement. And if the statement is false, that means the inequality has no solution. So you would write this. Or you write down what I believe you'd find in the back of your textbook when you check your answers. No solution, or they'll write the symbol for the empty set. A 0 with a line through it. I'll take either one. Either one will do. Now, because there's no solution, there's no graph, and there's no interval notation, because the solution does not represent an interval on the number line. And there's no graph, because it's empty. There's no solution. Done. Now there's 4.1. I don't think I'd change anything that I said. I just hope that it gets on board and it gets processed and everything, because I think it's a good explanation of that section. We'll be moving into 4.2. We'll take a little bit of a break right here and we'll move into it. Take care of yourselves and we'll rejoin you. Bye-bye.